Welcome back to our Scala class, and we will continue looking at various traversable methods. Again, when I'm talking about traversable, that really means actually iterable, so this actually covers all of the collections, data structures in our Scala collections. And again, there might be a question, where is an array in here? Again, you don't see an array here, it is technically should be here, right? Actually, if you look in the documentation, array is actually the Java array with some extra magic on top of it, so it's sort of wrapped. The array is actually wrapped and it gives us same methods we are going to be looking at today, continuing to looking at today. So it looks like, again, so almost everything here, basically pretty much everything, we can use the methods we are looking at. So we looked at our day 4. We looked at some of the drop while and of course the well-known filter, and we saw also filter not. Let's continue with the drop while, and I will with its alternative take while. There is also a take while, right? So I'll make a new file, day 5, Scala, collection methods, again methods, and of course an object, right? And add extend zap, and again more collection methods, and again the canonical, the list here is here, right, from the cookbook, right? And we should be able to cover most of these. Like I said, we know quite a few of them, but still it's a good thing to repeat also, and also so you can, your knowledge gets a little bit deeper. Right, so we'll start with some array, of course. Again, well, I'll do numbers, right? And I will do something again, maybe -5 to, I don't know, 12, right, to array. Again, I could have used list or vector, of course, but and of course, so print line, right? We know this is, of course, numbers, make string, right? Okay. We should have the numbers, right? Compiling. Right. Okay. So. And maybe I should have I should concatenate do it twice, right? So we can see some extra numbers, perhaps, right? So you could see, maybe I'll add double. So double numbers, right? We'll do double cloned numbers, right? Or double numbers, right? Double numbers we could do basically, or duplicate numbers, right? Will be numbers concat numbers, right? Right. I wonder if we could do, right, and this will be, of course, print line, right? This is something we did yesterday. Print line, duplicate numbers, and of course we'll get make string. Okay, we should have all these numbers. Maybe I'll make something smaller so we don't have too many. Maybe I'll do like 7, right? So we have, again, yeah, okay. So you have duplicate numbers, right? Twice. Okay, right. So drop while predicate will be this drop sum, right? We'll do dropped. Let's say negative drop neg, right? It will be what? Duplicate numbers, drop while, right? And we'll do this drop while is under 0, right? Something like this, right? So we already saw this print line, drop neg first, right? Actually neg and make string. So this is again drop while. So only the beginning will be dropped, right? Exactly, right? So these negative numbers remain. So this again, again drop while drops until predicate. So predicate function stops being true. So there is also, it's, you could say, cousin or brother or sister. There is also take while, right? Remember what take is, right? So take some, take 5, right? Take 5 is, of course, let's say we have duplicate numbers, right? Take, let's say take 5, right? And of course, print line, take 5, right? Again, I'm lazy to do this quicker, right? Quicker, right? Right, so minus, okay, so we took 5, right? Okay, right. Again, I'm using toList because it's quicker types and make string basically, right? That's again, there's no real, that's just for show purposes. Again, I could have stayed with the list in any case. Okay, so we know how take 5 is. So take first fake, to take first 5, right? Okay, we already covered this a while ago, right? So now we have dropped while and we have take while. So how does it work? Basically, take while it's true. So while take while numbers, right, will be, so duplicate numbers, take while, right? And again, so let's say again, so what will happen? It will take these, right? It will take these numbers, right? So let's see what happens. Print line, take while, numbers, toList. So what will happen? So there's a predicate, right? We take while this remains true, right? Let's see. Let's see what happens. We only have it here. Take numbers, take items, right, until predicate stops being true, right? So yes, right, -1. So let's say minus, of course, if I change this, right, again, take, right, so it's exactly the same. So maybe I'll change this to I should do maybe 3, right? The name is to take 3, so it doesn't interfere. Take 4, right? So of course I'll do this 4, right? Okay. Obviously, right? So this is takes. So this is sort of, again, so you could say that take while, take while and drop while, right? They are sort of together. You should be able to construct the original list, because this takes and this drops, right? So this keeps only the ones where it's not, right? So these are sort of reverse functions. But what's more interesting is, well, there is also a span. So this will give you 2 collections for both. So you can combine, right? Turns out there is even a span method which will give us a collection of both drop while and take while, right? So how does it work? Let's try it. So span numbers, right? Span collection, right, will be, let's try this. So duplicate numbers on span. Yes, span, and again my predicate will be very simple. Let's say minus less than 2. Okay, something like this, right? Something very simple, right? Simple function, right? So what is this going to be? Is this going to be, yes, array? So tuple. So this we get. So we get a tuple. So we get a tuple of 2 arrays, right? Let's check, right? I assume it looks like tuple to me, right? Span collection. Yes, indeed, it is a tuple, right? So, right, this is an array, right? Make string. So this is, again, so this is like again, obviously it's not completely necessary, this span, but it's a very nice way of, you can sort of split, right? So you get drop. So first one is, so this will be the drop. I wonder, do we have anything fancy? No, unfortunately we don't. Right, we don't have a name, it's just a tuple, right? Looks like, certainly looks like a tuple, right? So this will be, make string, will be, right? And of course, similarly, I'll do 2. So this will be give us, so this will be drop while, and this will be on take while. I assume, right? Let's again. So this is something again I don't use this often, right? So, but it is quite. So yes. So we got the first part and we got the second part again, right? So remember this wait again. It only stops dropping and taking as soon as this predicate turns false, right? So at 2, right? It drops these, right? So that's collects in a. So this was a drop while, no, or was the reverse? Yeah. So or take while, right? Let me check. I think this is. Let's collect again. So yeah, take while. Oh no, actually yeah. So this is actually take while, right? To be correct. This will be take on. This will be drop while, right? Again, so the reason again I don't use too much, but because this I don't particularly like this syntax because you can't tell what it is, right? I have to this tuple syntax again. It's not immediately obvious what kind of object you are working with, right? So probably again most times you would want to maybe do it separately, drop while and take while separately. Otherwise you have to inspect which one is first, right? So drop, take while, right? We take, right? This is we drop, right? We drop until it's -2, right? I mean, unless as long as it's under 2, right? And of course, again, so it keeps and then stops. Then basically, it stops working. Basically, and it stops. Right? Okay, so that's how we can use take while, and also we can combine both drop while and take while with the span. You see, splits array into prefix. Okay, you can read the instructions here. Prefix suffix pair according to predicate, right? So you can write it also. So you could use. Okay, so basically what it is, they say it's more efficient. You could do the same thing like this, right? C take while P, C drop while P, right? So no side effects, right? There's not. Of course, this should have no side effects. It shouldn't launch any rockets or anything like that, right? It should be a simple, predicate function. When I say predicate function, of course, it's something which returns true or false, right? So again, I could do this. So similarly, I could do this same again to illustrate this point. Also, span collection would be this, right? Would be like this, duplicate numbers, right? I could do span, and of course then I have to have my predicate function, right? And I don't like writing this. I mean, this also would work, right? And you could write it like this, right? Duplicate. I mean, not span. Sorry, with a drop. How did they say it? Take while. Yeah. So take while first, right? Take while, right? On duplicate numbers. Drop while, right? And also would work, right? This is also exactly the same. You see, it's exactly the same. So of course I would show, right? So and we could do, of course, if we did not know span, we could do the same as above with by hand, right? That's again, I like this. I like the parenthesis. I mean, so again, so I could right. So this is same thing as, of course, right. Right. I prefer this syntax, right? It works, but take while, I like this one better, right? I don't know. I'm slightly more biased to this syntax. I mean, this is fine as well. Again, there's no. If you like it, you can use it. Again, the main thing is try not to. Unlike me in teaching, you should stick to one in one project. Use one type of syntax, right? And unless it's absolutely there's no. So this I think is same thing basically, right? I mean less dots. But I like dot notation actually. I like dot notation, right? So, and we'll see this is also span collection, and also span collection, right? Okay, and should be exactly the same. Line. And let's run it, and I expect same results. And yes, exactly the same results. Okay. Right, so let's move on. Right, so we know span. What did we not check before? We checked for all. Let's do some flattening, right? Right, so this might be useful. Find, did we check find? Find also. Right, so we could find, right? That's also actually quite nice. So let's find number which is less than more than 3, right? So first find will be duplicate numbers, right? Again, and find n. We could do this, divide by 2 equals 0, right? We could do this, right? First even number. So first even number, right? And it should be, if we start -5, so it should be -4, I assume, right? It should be -4. Let's see that line. First even, it should be -4. Let's see. Sum -4, right? Actually, it finds, but thing is also right. So notice it's sum, returns sum, right? Returns sum, right? So because we might not find anything, right? So what we could do is, of course, print line first even number, get or else, right? Get or else, I don't know, -0, or not found, or something like that, maybe, right? Assuming so here, or -1, right? So here using 0 to indicate we found nothing. Of course, you could adjust as needed, right? Of course. So let's see that, and we have -4, right? Again, because this is of course potentially find first number, first item which matches predicate, which returns true, where on which predicate function returns true, right? Okay. All right. So find is easy. Of course, we used quite a bit. So flattening. So let's do a 2D array. Let's see. I'll do tuples. Okay, so let's do tuples, right? So our tuples, we'll do something like this, array, and I'll do something like this. I don't know. I'll just do random, right? And I'll do completely random stuff, right? I don't know, right? Something like this, right? Completely random. So this is a collection of tuples, right? And this is, of course, indeed really array product is serializable. Actually, it doesn't. Let's see. I thought it would actually do. Maybe I didn't do it correctly. Let's check, right? Print line. Are tuples. I don't know. Make string. Let's see what happens. I don't know. Maybe I didn't do it correctly. No, it works correctly. Okay, right. So we have a 2D, some sort of 2D. I could, of course, do array, of course, right? I could do array, right? So, if in fact, right, 2D array, right? I could do array, right? And then, of course, now it's going to be any, right? Serializable, right? Array, and again, array, right? Array of integer, right? So this will not look very good now, right? See, it has memory, just because array, that's the only downside using arrays, right? I could use, of course, lists, right? I could do array of list, for example, right? List, list. Again using list because using list because I'm lazy to print, right? So, right, list. Okay, but it's of course 2D, right? So flatten, flat R should be our tuples. Let's see how that happens, right? It should be flatten. And the question is no, right? Flatten, is that it? Is that enough? Yes, looks like it should be enough, right? Excellent, right? Flat R, make string, right? On. Yes, so a flat list, very nice, right? I think quite useful, right? And now again, a Scala likes to give us extra methods to work on. And let's see how we're doing on time. We're doing good. Yes, we have time. So we can combine map flatten with map. By the way, let's check. Could we do something even crazier, right? We have array of tuples. Could we flatten even 3D? It's not been covered, maybe, but let's see about this. Let's do 3D array, right? So val r3D, right? Be something like this, right? And I will do again. I'll do maybe array. And let's say array, right? And then you have array, right? And let's say, right? And we have, of course, again, array, right? And then now we have this is gonna get array, right? This ends the one here, and then we do one more array here, array, you know, right? And again 2D, so 3D. Right, on right. Okay, so this means if we want, let's do 99, right? 99. How do we get 99 here? Let's check. So should be print line R3D. Let's check. This is second. 1, 2, 3. So we need to use what syntax? Again. So we need to use 1, right? Okay, all right. I can't type it like this yet. 1. Or maybe I'll use lists for this, right? So you can easily see list. Same thing. All right. Let's do list. It'll be easier. Control H. No, not Control H, Control Replace. I want to replace because why? Because it's easier to understand because I'll just copy it with list, right? Control D. Oops, not like that. Control Z. Control D, right? We'll skip this. So this will be list 3D, and I will use this controller. Yes. So array. And I will change it to list, right? 7. So, and I want to do it here in this part here. Yeah, replace. Okay. And so list 3D. Right. So this will be this part here. So it will print this part here, right? Let's check. Yeah, so 99 would be what? 99 would be 1, 1, right? And then 3, right? Yep, so 99 would be here, right? So we take second, and we get fourth item, right? So 3D, list 3D. Right, so we have 99 out, right? Of course, you could take, Control D. I could do, of course, I could do tail, right, or last, right? I could do this. This would be more, you know. I could do last. I could do last, right? I could do last. Same thing, right? last, right? For lists it will be very similarly, right? Also 99. Okay, right. So but that's more of on a list manipulation. Okay, so let's flatten. So let's flatten this whole thing. Flat list. Well, flat list will be list 3D flatten, right? Let's see what happens. And of course again I can type on print line flat list, right? Let's see how flat really it is. Yeah, so it's not that flat actually. Let's see. Flat list 1. It looks like certainly, so we need to flatten twice apparently, right? And let's flatter list, right? And so it will be what list 3D flatten. Can we do that? And again I can't do this, right? So can we do this? Looks like, let's try this one. Flatter list, right? Yes, okay, so, right, of course I could do this, of course, I could do this also, of course, this also, of course. So I need to flatten again, flat, more flat, right? More flat list would be, of course, also flat list, flatten, right? As you can imagine, same as above, more flat list. Again, I'm using list because I don't have to convert array. You know, it prints nicer, right? Again, list is very nice. It's nice for smaller data structures, but again, it shouldn't be used for larger data structures because it's going to get slower. But again, so yeah, flatten. So we need to so 3D list, 3D collection, you know. Sequence, actually, hey, sequence needs to be flattened twice. Okay, all right. So let's go back to our array tuples, right? Now it was this array of lists, right? So we could do a mapping. So we could do flatten and unmap together. So we can. There is a flatten map, I believe it's called, yeah, flatMap, which combines flatten with map, obviously, right? So we'll do some mapping. So I'll do this flattened unmapped. All right, so he'll do this. Will be we'll have array tuples, right? And we'll do flat map. We need a function, right? So let's do times 100, right? Something easy, right? I believe that should work, or maybe I don't do it correctly. Okay, let's read why we didn't do it correctly. Build a new array by applying a function to all elements of this array and using the elements of the resulting. No, it's not quite what we want. Well, not quite as easy, right? So applies a function to all elements of this array, right? And using elements of the resulting collection. Why doesn't this work? I wonder. Let's see. Let's look at examples. So it's not quite what I want. The Scala flatMap Alvin. Let's try this again. It's not quite. Right, fruit uppercase, so flat map, we did this, right? So flat map to uppercase again, so map and flat map, right? So you have fruits, right? If you map to uppercase, it will be apple, banana, orange, right? But here this would be a good example, right? So we have sequence of apples, right? Let's look at this example. Not quite what we want. I wonder why it should work. Actually, it should work, but maybe our tuples, right? List of integers. should have worked. I would have expected to work. Build a new array by applying a function to all elements of this array and using the elements of the result. Function to array, and we should be getting an array of flat array. Maybe perhaps it's not. Maybe it's just syntax here. Maybe it's not. It can't pick up on this, right? So maybe I need to do this. Can I do this? Nope, I can't do that either, right? So this is not quite what we want. So what can I do? This? No. Interesting. This works, right? So this is just flatten, right? But because this is just n to n. But why can't I do, let's say, plus n? This is no, this is not quite what we want, right? So interestingly enough, it doesn't quite. This is just flatten, right? So this works. Something doesn't quite work here. Okay, we'll check. We'll get back to this example, but let's see how it. Again, not something. Usually, I would just, if I personally would use flatten, I use flatten and map separately, of course, right? But the example here is to have fruits, of course, right? See the difference, right? We have our fruits, right? And then we have our map to uppercase, which we know, of course, right? Line, right? Apple, banana, orange, right? Of course, this means for each string we are uppercasing it, right? So flatMap, of course, will be on then to uppercase, right? So this should be very similar, but not quite the same. Oh, one more. I forgot the bracket parenthesis. Yeah, so this gives you a list of these numbers, right? Of course, I could do map and flatten, right? Let's try this. Is this the same thing or no? Right? So will this work or not? Let's try this. See this happens. Or maybe reverse. Yeah, it's the same thing then, right? So question is, why doesn't in this particular example it works? This works, but why doesn't this work? Maybe our tuples, you can't use this number uppercase because you see it's using it on a whole string, right? So I know what happens, right? So probably what it was. You have to write something even sillier if it's an item, and what to do with the internal. So it's not that useful actually. Well, it's useful, but so how to do this? Now that we have this, we could do something like this here, and then we have to do n for each, right? And we have to map again, right? So n map on something like this, right? Times 100, right? Yeah, this is legal. Yeah, this is legal, right? And then we'll see, right? Print line. And it's of course, it's an array. Of course, it's an array. So we make a, to list. Yeah, you see. Okay. So what happened here, right? Is that we have the 1, 2, 3. See, 3, 1, 5, 3, 2, 1, 6. Yes, 3, 1, 5. Right, 3, 1, 5. And list 3, 1, 5. Let's see. What didn't work? Why didn't actually no? So our tuples. Wait, I should probably print our tuples. What's actually happening here? Right. Okay. Yeah, 3, 5, 35, 32. Yeah, it's everything is accounted for. So the problem was, well, again, so to use flatMap, since internally, right, each item is a list, right? So you can't just multiply list times 100, right? what you can do is, right, you can do something with each item, right? You could do this, right? You can map each item of it internally. What we could have done is we could have doubled it, right? It's also, we could do something very silly. Dupe internal items, right? We could do this, are tuples, flatMap. Let's try this. And we could do n, right, or a list, you know, list equals list plus list. I think we can do this, right? Yeah, I think we can. No? It should have worked. Concat, concat. If we can't do so, what to do with this each item? For each item, you want to do, if this is a list, can't we concatenate? Again, I'm not, maybe it's not overloaded. I can't do this. I thought I could. Yeah. So it will duplicate, right? Print line, do internal items to list. Okay. So there should be, what should happen? We had this, right? It will have duplicate 3, 5, duplicate this, and also duplicate this, and also it will be all flattened. I don't know where to use it, but quite powerful, right? Yeah, indeed. You see, flat, but also duplicated, right? Of course, I could have done more mapping. I could do some crazy stuff, right? I mean, it's very powerful, right? Very concise notation, but again, it's kind of maybe harder to follow, right? So again, I wouldn't say don't worry too much about flatten. I think is more useful, more practical. Again, if you're flattening, and then you can do this. I think again, divide and conquer strategy. Maybe don't try to do too much at once, but do it in smaller steps. But of course, Scala gives us extra options. So we know flatten, flatMap. We only covered fold all, right? And also, let's see, we can do also something this. Let's see, do we have a first even number? No, let's see. We had drop neg, right? And we could check or all over all less than 100, right? We could do this. This is predicate to it's for all, right? So for all, duplicate numbers for all, and n, you know, less than 100, right? And this should be true. Returns true if all of them are less than 100, right? And this should be, of course, it's a boolean, right? Yeah, true. Obviously, right? It's all true. And of course, print line, duplicate numbers for all less than 10, less than say 2, you know, on 1, 2, 3. Ah, here you go. Yeah, should be false. False because some are 2 or more. So that's an easy one, right? So again, reminder that for each is just a loop, right? For each gives loop. I guess again we are probably gonna have to stop this pretty soon. So we can do something internally. We can write, so we can use for each instead of for loop, right? So we could do something, but again, then we need some sort of well, but for each, you know, but for each mostly would be used for side effects, such as printing something, print line, or writing, maybe writing some function, calling some function. So it's not the same as mapping, right? It's kind of similar ideas, but we are doing something, right? Not returning a new collection, but say again duplicate numbers, right, as classical example for each, right. We can print it like, you know, n. We could do this, right, print line, you know, number is n, right, something like this, right. Classical. So we give an example, do something. So we give an example, we provide a function to do something with each item, you know, right. I mean, you could send it out to a network connection or something, or save in a database or something like that, right. You know, could be print network call, save into database, something like that, right. Some side effect, right. If you want the data, if you want to transform, save into different data, then map or for yield construction would be preferable, right. You know, this is again something we used before, right. So last thing which we'll get to is groupBy, right, and this is very cool, right. So groupBy, so which will be useful when we start with databases next week, continue with our databases. So groupBy takes a collection and groups it according to function, right, we provide, right. So similar analogies with groupBy in SQL, right. So we have our numbers, right. So groupBy divides by 4, for example, right. So well, grouped by, again, so a classical example would be even odd, right, would be duplicate numbers, groupBy, of course, and we provide right, this, right. That's the classical example, right. And we'll have a mapping integer, so this will be 0 and 1 here, right. Let's print. So print line for key value in even odd map. It's gonna call map. Only problems I need, this is tuple, I need to write this, and you know, reminder key, and we have value. This will be, what will be value, let's see what type it is, array, right. So I'll do, you know, value to list, right. And let's see what happens, right. So we'll have, see all the numbers, right. We'll have a big list of numbers right here. Maybe I'll just do numbers, right. I'll just, so we don't have to have, then I'll just do numbers because we have less numbers to worry about, right. Right. So what's interesting, this is reminder 1, 2, 3, reminder -5. It's not quite, this is modulo, right. For negative numbers it works slightly differently, right. So it has reminder -1, so something, so actually it divides in 3 sections, right. So something, so not works slightly differently on negative numbers, right. Using on negative odd number will give us -1, not 1, as you know. So that's the thing, one of those things. So modulo versus, this is modulo versus reminder, right. This is modulo versus reminder. Wikipedia is, yeah. So Stack Overflow, right, this is one of those cases, right. it's in many languages, of course, right? So, right, yeah. Positive values, there's no difference, right? Right. Yes, it depends on the language, right? So it depends on the language. So depending on language, so depends on language, right? Right. So yes, so this is actually mod apparently, right? So on the or am I reverse? Modulo, right? Right. Or reminder. Sign or reminder will be same as divisible. Ah, so module will be same as divisor. Oh, okay. That's interesting. So this guy also has, well, he's kind of has very little, right? So reminder -1 modulus, right, will be right 1. Okay, yeah. So this is reminder. So this is, so it looks like this is a reminder. Okay, but okay. So let's say I have positive numbers, of course. Again, some we have our fruits. Where's our fruit example? Right, banana, apple, orange. Right, I could do by group by length, for example. Right, so well, my fruits, more fruits. Right, I'll do fruits plus. Do I have sequence? I don't know. More fruits. What is it? Peaches. I don't know, nectarines, maybe let's do, what else do we have? Berries, fruits and berries, right? I don't know, cherries, I don't know, they're not really fruits, right? You could say that, right? What else? Apples, that's apple fruits, or pears. So okay, let's see. So this is it incorrect? Fruits is sequence. This is should be sequence 2, or this plus plus. I forget now. Yeah, okay, plus plus. Okay, yeah. Sequence string. So of course, print line. More fruits. Right. Yeah. Okay. So we can group by length. For example, group by length. Right. It will be of course more fruits. Group by, and I could do just a size or length, right? I could do this, very simple, right? And then of course, then we'll do this for doing this key value. Very powerful technique. This group by is extremely powerful because you can group by pretty much, you know, anything you need, right? So more fruits, right? And let's see what's happening here. And where is my fruit? Oh, group by. Oh, sorry, group by, not group by length. Right, and then we can do this, right? Of course, I could yield. Of course, oh, not like that. I could yield it here. Right, on length. So this is what? It's a map, integer sequence of string. Right, this should work quite nicely. Right. Again, so sequence by default actually goes to the, so sequence goes to list by default for smaller sequences. Again, sequence defaults to list for smaller sequences and to vector for longer ones. Right. Again. Yeah. So. Reminder, it's not reminder, it's length, sorry, length, but same thing, of course, right? It's just the text, right? Length. Yeah, it's finished. So, length 5 is a list of apple, list nectarines. Notice also it's not, the keys are not sorted, right? We could, of course, sort it by, we could have a sorted map, right? So I think I also made a debug version. Let's try this again. I think I ran the debug version. Yeah. Okay. Yeah. So 5, 1. I revised this order because it is how we cherries was last. Right. Actually, this yeah, cherries, 8. Pears, I'll leave a cover. So peaches, right? Nectarines, not quite immediately. So the orders again. So the order is not guaranteed. If you wanted order guaranteed, we would have to use a sorted map, right? That's again for next discussion, for maybe later on when we do the exercise. I think it's time we come up with a nice exercise, and we'll do that in the next video. Thank you.